All right, well, first of all, thank you for coming. I don't like to be the only one talking. I hate the sound of my voice, and it's also reflected back to me, so it makes it really awkward. So at any point, if you have questions, please raise your hand. I might call on you, I might not. Nah, that's life, right? I'm Ruben Nick. I'm a phone stuff engineer at ShowClicks, and let's talk a little bit about TypeScript. I do want to open it up that I feel a little bit bad about the title of the talk, because even though I said I would emphasize on talking about how to integrate TypeScript into kind of existing code bases, I touch on that a little bit, so but not too much. So I feel like I kind of baited and switched you guys. I got to be honest with that. Sort of what I actually did is I wrote a talk kind of about types and why are types important, because I feel like in the JavaScript community, types are still kind of, a really new thing, right? We all have, PTSD flashbacks of public static void main from like when we had to do Java for that one class. But it's not all that bad, I promise. But before we get started, there is this little checklist that I think is really funny and kind of a great way to examine languages, called the Programming Language Checklist by all of these people who are much smarter than me. So let's run through this checklist with TypeScript. So the first one is, you appear to be advocating a new, check, multi-paradigm, check, statically typed programming language. Your language will not work. Here is why it will not work. You appear to believe that, check, convincing programmers to adopt a new language will be easy. Check, programmers love writing lots of boilerplate. Check, specifying behavior as undefined means programmers won't rely on them. Unfortunately, your programming language has, check, implicit type conversions, check, explicit typecasting, check, type inference. The following philosophical objections apply. Check, your type system is unsound. Check, a proof of the same is attached. Don't worry about if you don't understand this line right here, but that's a proof that the TypeScript type system is unsound because we're implicitly converting a type. Don't worry too much about what that means. And to me, that's not like a philosophical objection to not use TypeScript. But for audience participation, what would the type of X be? It would. Do you know which specific number? You can guess. 0. It would, yeah, 0. All right. Well, that's pretty good. If you want, you can have my empty water bottle. Yes. All right. Well, okay. Here you go. That's the best I can do. Please don't drink that. That's too late. Okay. All right, cool. Your implementation has the following flaws. Check, you require the language runtime to be present at compile time. Check, your compiler errors are completely inscrutable. And then check, dangerous behavior is only a warning. Additionally, your marketing has the following problems. Check, unsupported claims of increased productivity. Check, unsupported claims of greater ease of use, right? The unfortunate truth about us as software engineers is that a lot of what we believe about programming languages is not definitively proved, right? Like the amount of literature there is about like what makes a programming language easy to use and reduces errors and stuff, that just doesn't exist. So anybody who tells you that this is something that this is a language that scales, this is a language that produces less errors, we can't really prove that, unfortunately, yet. There's a lot of reasons for, but it's still worth noting. The last one, taking the wider ecosystem into account, I would like to note that check, you have reinvented JavaScript, but with types. In conclusion, this is what I think of you. Check, you have interesting ideas, but is it worth it? I'm crossing out the rest of it because as a community, we tend to be pretty bad about new ideas. But let's rephrase that, is it worth it? Now, with all of that said, let's dive into what types are. So let's say I gave you a bowl of fruit, right? It had apples and it had oranges. And periodically, I would ask you for one or another of the fruits. You'd probably wise up to this, and what you would do is you would organize them so that you could give me the correct fruit not only quicker, but if you gave me the wrong fruit, I'd throw it back at you, right? I would segfault. I would, just throw away all of your work, right? Now, what you could also do is you could do something like this. And if you do something like this, you're a monster and seek professional help. So types are very simply a collection of possible values. This categorization allows us to communicate what our code expects. But that raises the questions, if you have types, can you have an untyped programming language? You actually cannot. Let's look at this line of code right here, right? By the way, this is like modern JavaScript. This is just a very fancy way of creating a function, in case you're wondering. So we have this function full name that accepts a person, and then it concatenates their first name and then their last name, and it returns that, right? What happens if the first name is not existent on that object, right? We're expecting this parameter that we're passing in to have a certain shape. Because if it doesn't have a certain shape, this code is going to fail, right? But we don't write code like this, right? This would be the actual way to make sure that everything is the correct structure for the bottom line of code for concatenation to actually work correctly. None of us write code like this, right? Your coworkers would.
Sometimes I do.
Okay, sometimes you do. I'm sure you give very colorful code reviews.
Yeah, they rewrite it.
Okay. All right. Good on you. Thank you for trying. Yeah. But right, so we oftentimes don't write code like this. So there is actually no such thing as an untyped programming language. That's a completely unsound statement. It can't exist. Types are they're just categories of possible values, and the way that we programmed, we implicitly code, our data structures to expect, or our logic to expect certain data structures. IED, it's not IED, it's ID. No, like the
Latin phrase.
QED, thank you. QED, it's impossible to have something, an untyped programming language. Okay, well then what are the types of programming languages, right? Okay, so if you have to have types, what are the categories of typed programming language? Oftentimes you hear, strong versus weak, my language is strong and JavaScript is weak, right? That is actually a completely meaningless term. It has no resemblance to anything in type theory. This is a quote by Chris Smith. If you've never heard about him, you should look him up. He's a really big in the Haskell community, but he writes things and presents in a very understandable manner. He recently gave a talk about teaching Haskell to elementary schoolers, and I think it's a really good talk. Anyway, strong and weak typing. Probably the most common way type systems are classified is strong or weak. This is unfortunate since these words have nearly no meaning at all. It is in fact to a limited extent possible to compare two languages with very similar type systems and designate one as having stronger of those two systems. Beyond that, the words mean nothing at all. Therefore, I give the following general definitions for strong and weak typing, at least when used as absolutes. Strong typing, a type system that I like and feel comfortable with. Weak typing, a type system that worries me or makes me feel uncomfortable. Those words are meaningless. In fact, also, dynamic versus static, right? That's what we oftentimes hear, right? We're like, oh, well, JavaScript, it's a dynamic type system, and C and, Java are a static type system. But the truth of the matter is that it's actually pretty complicated. There's that's an oversimplification, especially with new features being introduced in like the C++ 14 standard and the Java 9 getting var, which is like infer typing, right? You don't statically have to type that anymore. C++ 14 getting the auto keyword, which infers the type as well. This whole like dichotomy of static versus dynamic doesn't actually reflect the real world anymore. In fact, what often occurs in our programming languages, our modern day programming languages. Ooh, I got a lump in my throat, excuse me. Is they have a variety of different characteristics. Here are a few of them. This is by no means an exhaustive list, right? There's inferred types, right, where the programming language or some type of tooling, whether that's your linter or your IDE or your compiler, infers the types for you and says, hey, I think this is a number, or hey, I think this is a string. There's dependent typing, which is something that's very new, and it's starting to like sort of become the rage with Idris, is you have your type sort of, because we think of like your types live in one world and your code lives in another world, right? And never shall they meet. Star-crossed lovers of some sort. Dependent typing is actually like inferring the types based. It's weird, but it's like based upon what the code might do. I'm struggling with like how to completely describe it. But basically, like one example of it would be like, if the code has this structure, apply this type. But if it has this structure, apply this type. It basically is embedding logic into your type system that allows you to have a stronger type system. Nominal typing is what we see in like Java, where that is, it's dependent on the names, right? So like if you have a class called vehicle and then a class called I don't know, houses, right? Even if they have the same structure, even if they have the same methods, which is like blow up, I don't know. You know, I don't know what vehicles and houses have in common, except that I own neither of them. Because they're a different class, even though they have the same structure, you can't use them interchangeably. They're nominally typed. Structurally typed is if two objects in your programming language have the same structure, then you can use them interchangeably. And even there, like structurally and nominally typed is actually starting to mix in programming languages themselves. All right, but like why, okay, thanks for, telling me a little bit about type theory, but like why do we actually even care about, this categorization of possible values, right? Well, here are some of the things that I believe, and then further on in the presentation, I'll show some examples of this. Types can serve as documentation. Hopefully they're not the only documentation you do, but they can serve as compiler-checked documentation, right? So like JS doc or Java doc, these are not checked by the compiler. They can diverge from the actual code underneath, right? Whereas types cannot. Types can serve as basic tests. This is sort of a reiteration, I guess, of the other point, right? Is that if you try to push in, if you define that your function accepts only numbers and you try to give it a string, well, that's a compile time error instead of blowing up in production. Types also make it easier to write tooling. And this one might, you might be, I'm a little wishy-washy on it. First of all, I just need you to trust me. All right, like I didn't come here to lie to you. But types, because you can specifically specify what an object is, right? It makes it, it gives the tooling another data point to make sure that you're referring to the same object rather than just going by names alone, right? Rather than like, control Fing in your whole project and being like, all of my vehicles are houses now. It provides tooling, it provides another data point to the tooling to say like, okay, even if they're called a house, but they're not of class house, he's only trying to rename class house. So it makes it easier to provide tooling. And this one is, I'm okay if you leave this room not believing me on this, because this sounds like a nonsensical statement. Types can make impossible states impossible. And what I mean by that is, you know, the best code is the code that can't error, right? Where like the error states can't exist because you've gotten rid of them, right? So like a great example of this is like maybe defining your, maybe you know that you're doing a division somewhere down in your data pipeline and defining your type in such a way that 0 doesn't belong in your type. Because of that, you can't have a division by 0 error down deep in your pipeline. That's a little bit harder to do, and that's okay if you don't believe me. So, how does this actually like look a little bit, right? Did this skip ahead? No. Okay. I think these slides actually got misplaced. I apologize. Cool. Now, finally, let's talk about TypeScript. So the first thing to note is that TypeScript is from Microsoft. That's okay. Microsoft is now our buddy, right? They own GitHub, VS Code. They contribute to open source software. They're one of the prime contributors to React Native and Electron. The devil is now our friend. It's okay. We love them now. But with all of that said, now that we've talked about types and we're okay that it comes from Microsoft, what are some of the features of TypeScript, right? Here are some of the features. It's inferred types, right? So you don't always need to specify your types. It can usually figure out what your type is through looking at your code. It's also structurally typed, which means that if you define a structure, right, like a JavaScript object that has a first name and a last name, and you say this is the type of object that I'm looking at, it'll accept an object that has those two and then has other properties as well, because you've just defined it as saying these are the only things that I care about. Give me something that matches this structure. And then it also has limited dependent typing, which means that during compile time, it will try to figure out what your code will do, and it might change the typing a little bit dependent on that. That's a very new feature, and it's really easy to shoot yourself in the foot with. So let's talk about, what are the basic types? How does this, right? Like, how do we actually do this? Well, the basic types are pretty easy, right? There's number, null and undefined, array, string, object. We all know the basic types of JavaScript, right? You run through these all the time. But, what's interesting is there's also like advanced types. There's types that we've built on, that TypeScript builds on top of those pre-existing types. Now, it's also important to say that even though I use the term advanced and TypeScript uses the term advanced, all of this does compile down into ES5. So anywhere that ES5 is runnable, it should be runnable in TypeScript should be runnable, right? Obviously Microsoft cares a lot about backwards compatibility. They still have people running, Windows XP, right? They can't get people off that thing. So the first one is the advanced type of any. So what any is when it goes to infer your types. So this box over here is VS Code trying to tell me like, hey, this is the type that I inferred. If there's not enough information or TypeScript doesn't know any better, it's just going to say like, hey, this could be anything. I don't know what it is. It's sort of the default type. If you take all of your files and from JavaScript and then rename them to TypeScript file format and run them through the TypeScript compiler, it'll probably think a lot of them are any, right? There's probably not a lot of type information it can use. Interface is the type of defining the structure, basically. By community standards, you always start interface with a capital letter I in order to designate it from like a class, right? Right, so this is like the structure I would be looking for in that previous function, right? I would be looking for an object with a first name that's a string and a last name that's a string. here's where it starts to get a little bit interesting. Enums, right? These are not actually super popular in dynamic languages, but an enum is it is a type that can only be one of those at a time, right? So it can the persons, can either be John or Bob or Brian. It can't be John and Bob, and it can't be John, I'm not going to go through all 9 different iterations of that, but you're basically saying this type can only be one of these, one of these categories, right? One of these instances. We'll get into why that's interesting in a little bit. And the last one that I think is worth talking about is never. And never is, according to type theory, it's referred to as the bottom type. And all that means is that it's a type that you should never call. It's a type that basically tells your compiler this code should be unreachable. So we'll look at this really quickly, and I'll walk you through this. So we have this greetPerson function, right, that accepts persons, which is an enum, right? We have 3 different types that can exist in that enum. And then we switch on that person, and we handle 2 of the 3 cases, right? We handle persons.john, and we handle persons.bob. But, we see this little squiggly line over exhaustive check. And what that means is the Typescript type inference was smart enough to look at this and say, like, oh, hey, you never handled persons.brian, right? And now you're hitting this never type, this type that you've told me I should never hit. So this is an error for you. That's all nice and good, but what about tooling, right? That's what I think actually makes TypeScript, worth looking at. The first, big, sort of tooling around TypeScript is the compiler itself. The compiler is great because it allows you to choose the level of typing that you want. TypeScript, by default, when you integrate it into a project, goes with the most limited typing that it can, which is, it tries hard to infer your types, but if it can't, it falls back into any. But you can set properties on the compiler to make your code more strict, right? You could say strict null checks, right? Because any JavaScript type, string or number or object, can also be null, right? Or undefined. Thank you so much, JavaScript, for making a distinction between null and undefined. That continues to haunt us to this day. But if you set the strict null checks on the compiler, it will say, like, hey, you're using this object assuming that it's going to exist. You haven't proven to me that it exists yet. So if you don't do like an if, persons is equal to null clause, it will throw an error for you. There's also the no implicit any, which tells the compiler, anytime I can't infer the type and I give you an any, that's now a compiler error. Right, so you can choose these, you can choose the level of type safety you want with TypeScript. Just in case you're really wondering, I actually don't do strict null checks or no implicit any. I would love to do that in my code bases, but I unfortunately, have sprints to finish, right? You can also set it to not compile on type errors. That's not a default setting. Once again, TypeScript really wants you to migrate, your code base to it. It's built to support, migrating ones. So none of this is on by default. But what you can do in the compiler that I think is really nice is that you can actually finally enforce immutability, right? In the JavaScript ecosystem, it's very common for a method to have an underscore in front of it. What does that mean? That means that's a private method and you shouldn't call it, but nothing stops you from calling it. Well, TypeScript allows you to enforce that. If you set a private method, it will be a type error if you try to call it. You can also set read-only properties. so that they cannot be modified by anything. The other big thing about, tooling that sort of comes with TypeScript is VS Code. And some of the things that it comes with is it comes with refactoring support, which is, it allows you to rename across your whole project. I've used this many times before. I know that's one of the horrors of JavaScript is renaming across a project. Because TypeScript can have type inference, I actually have never had renaming across TypeScript projects fail on me. It also has go-to definition. So you can instantly click on a definition and it'll shoot you to where that type is defined. It'll also surface the type, the type inference, and it'll give you some of the documentation of this function I infer, accepts numbers, right? Or I infer that it accepts this structure. Okay, but how do we use it with existing JavaScript code? I would say there's two main ways right now. The first one is you can run any JavaScript code through the TypeScript compiler, and it will just spit it out normally. But if you do / space @ ts-check, that will run the TypeScript inference on that JavaScript file. There is also a GitHub project called TypeWiz, right? TypeScript is already doing this type inference in the background. What TypeWiz does is it just automatically applies that type inference to that JavaScript file and prefaces it with TypeWiz because sometimes it's not going to be 100% there. Here is the thing that actually really gets me about TypeScript is that you can use types to create new tooling. And here are some of the ones. Exhaustive type matching, right? This is, exhaustive pattern matching. This is a feature that is not available in JavaScript, and you can't. It's just not supported by the language. TypeScript allows us to do that. This is the same code that I showed earlier, right? An enum. I'm switching over it, and because I have that never type, TypeScript is smart enough to say hey, persons.Brian is never assigned here. You're trying to assign it to never. I need to define persons.Brian as a case in this switch statement to get rid of this error. And this is known as exhaustive pattern matching, right? I'm looking at a pattern, which is my enum, and I need to check each one of those patterns before the code will allow me to continue. The other thing is a localization existence. By a raise of hands, how many of you localize your apps? Okay, right? One big error that can creep up is having a localized string in one language and not in another, right? And oftentimes, because these are done, by existence on a dictionary, you can use TypeScript to extend the type definitions of your of the library that you're using. So this right here is how I extended the type definitions for React Native I18N in order to support our translations. So right here, when I then go to translate this specific, look up by this specific key called test, it suddenly becomes a type error. And every time that I add a new translation dictionary, it will also warn me that those translation dictionaries don't have that key. So now this becomes a compiler error instead of an error on production. The other one, this one is a little bit, it uses a little bit of dependent typing, and if anybody's wondering how I actually do this, I'll talk to you after this talk. And I'm willing to share a little bit of code, but I can't share too much because, it gives away secret sauce and all of that stuff. But you can also use TypeScript for Redux Action parameter existence, right? So you can look at this error right here. Test is declared, but its value is never read. And also type, blah, 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 has no property test and no string index signature, which is basically saying on On this Redux action, this parameter that you're trying to use doesn't exist. You can create this type of tooling through types. But, it's not all sunshine and rainbows. There is a price to pay. The first one is types have an image problem, right? A lot of us started programming in, C or C++ or Java, right? That's oftentimes what computer science education started with, right? I know now they're moving towards Python, which is great. That's so much easier of a language to begin with. But, right, we grew up hating the compiler. We grew up hating types, right? I've lost track of how many times, I did array, open greater than, and then, dumped some garbage in there, and then another, close, greater or less than sign in order to get the compiler to shut up at me. I think this is starting to become a non-issue because of type inference, right? Oftentimes the compiler is smart enough to actually just say hey, this is the type I think you mean, instead of yelling at you, and telling you that you've gotten it wrong, you're an idiot, please go away now. So the other thing is mixed bag error messages, right? Types can give you some pretty weird error messages, as I'm sure anybody who who has messed with C++ can tell you, right? Types can get some pretty nasty error messages, and honestly, TypeScript kind of has this problem too. This is just a React component I'm trying to render. And the part that I actually care about is way buried down in the bottom. That property onPress is missing in type, empty object, right? So much of this is just garbage and noise. So honestly, the error messages for TypeScript they're a mixed bag. Some of them are pretty good, but as soon as you start using it in more complicated ways, and especially with React and Redux, the error messages can quickly devolve into garbage. The other thing is, right, a lot of us do JavaScript here, and who really wants another, level of tooling, right? We deal with this all the time. It's just, right, we run our code through Webpack, and then from there we also minify it, and we also, run a preprocessor on our CSS. There's it's one of those things where one engineer sets that up for a week, and then you never touch it again, because if you do, it blows up and nobody knows how to fix it, right? And it is another level of tooling, and that's to be, and that creates quite a lot of complexity. I think this is starting to go away a little bit too. Babel 7 is on the horizon, and Babel 7 has a plugin for TypeScript. So you no longer will have to do a weird conversion of trying to pipe the TypeScript output into Webpack, and then from there run all your other preprocessors on that. So it should get better, but it is unfortunately another level of tooling. The other thing is the JavaScript community is unfamiliar with types in general. And with that to say is types kind of have a steep learning curve. There's no way around that. And I think it's worth to note that you can't just switch into a project and instantly expect everybody oh, I suddenly know what structural typing is now, and I suddenly know how to set all of these types correctly. I actually have an intern right now, and he's new to TypeScript, and I swear 50% of my code reviews are hey, this isn't typed well enough, I would do it a little bit differently, and I'm sure he's probably going to leave this internship and hate TypeScript. But it's there's an unfamiliarity with types, and that's to be acknowledged, right? With introducing TypeScript to a team. So with all that said, we have to circle back into the the starting question, right? Like, is it worth it? I can't answer that question for your team. You're the only person who knows what your team is capable of doing and what they ultimately want to adopt. I can tell you that the teams that I've worked on where we've adopted TypeScript, it's worked out really well. And I've seen it used in new projects and slowly being adopted in pre-existing projects. And I think Microsoft has done a really good job of like slowing the introduction to types. But I think you should really go off and look at that on your own. On the TypeScript webpage, there is a really quick, like they call it like a 5-minute tutorial. It's not 5 minutes. It should take you about 15 minutes, but it's one of those things like, a senior engineer like writes that up and he's like, oh yeah, I totally did it in a day, guys. It's like, nah, it's going to take anybody else a week. I highly suggest looking at that. I highly suggest looking at TypeScript. With all of that said, does anybody have any questions? Yeah.
How does TypeScript compare to other attempts at adding types to JavaScript, like closure compiler and what?
Yeah, so the closure compiler from Google, they do type inference, but they don't add types onto the language itself. The other one that I've used is Flow from Facebook. The one thing I'd say about Flow is Flow has the first thing is like Flow's tooling is pretty immature. Take this with a grain of salt because the last time I looked at it was a year ago. I really hope that their tooling has gotten more mature. But when I used it, you basically had to use Atom. You had to use their plugin package called Nuclei, and it just didn't work. It would constantly crash on me. The other thing about Flow is that we talked a little bit earlier about like no implicit null, right? So like TypeScript assumes, hey, anything can be null, right? Flow by default, if you tell it it's just a number, it's going to say this can never be null. So there's a diversion right there with the two different type systems. The other big diversion with Flow and TypeScript is Flow is nominally typed on JavaScript classes, which means that if two JavaScript classes have the same structure and you try to use them interchangeably, Flow will throw you an error, and TypeScript will be totally fine with it. But to me, the main thing that pushed me in the direction of TypeScript versus Flow is the tooling. There's just a lot more mature tooling around TypeScript.
The immutability that you talked about, is that just a variable itself or mutations of any sort? Like, for example, there's an array you push onto it, is that considered also a mutation that would block?
I don't know. Let's find out. I don't know if the array mutation would be considered a mutation or not. Let's.
I think the read-only modifier, I think it's a shallow one. So if you define that on an object, there's an object inside of that, that will be mutable. But you have to apply read-only. Yeah. But I'm not sure about the array question.
Yeah, I'm not sure about the array.
Sure that it'll let you modify the array contents, just not assign to it. Yeah, well, Constal, I think Constal did the same thing.
Yeah.
Behavior of JavaScript.
So what's it
It's
called?
just
So
whether it's
const you can
class
still
or-
push onto an array. Right? You should. Is that the? Yeah. Huh.
You can push onto it with const, you can push onto an array, you can add properties to an object, you can modify the properties of the object.
Yeah.
This protects the
Yeah. So it looks like over here, read-only modifier can only appear on a property declaration or index signature. This is a great example of a error message that makes no sense. Oh my goodness, sorry, you guys can't see my screen. I'm like over here typing away and nobody can see what I'm doing. Let's mirror my screen really quickly. So, right here, yeah, it looks like you can't apply read-only to const. Huh. I guess you can only.
It has to be on a class or an interface.
Yeah. So I guess to answer that question, you can still apply. Yeah, you can still push onto a. Excuse me. Onto an array. It looks like. All right. Any other questions?
Another one. At TSCheck versus Typewise, they both output.
I'm sorry, I couldn't hear the last part.
At TSCheck versus Typewise.
Versus type what?
Typewise.
Typewise. Oh yes. So the difference there is Typewise will apply the type inference to that file, right? So like if let's change this really quickly and say like, hey, this is just a JavaScript file. Don't worry about it.
Keep the .back file. Those other converters.
Yeah. So.
Sticks it into like a new typewise file, I assume, right? Something .typewise.js.
Yeah, so you can modify it how it outputs. TSCheck will do it inline, and inline is probably the wrong term at TSCheck. Cannot block scope. So it will not, TSCheck will not modify your file. It'll just apply the type, TypeScript type inference. So like right here, it's saying like, hey, this could be any, you know what I mean? It doesn't really know. It'll just apply the JavaScript, the TypeScript type inference, whereas Typewise will go through and look at this right here, right, and say like, hey, you're only using that for numbers, so I really think you mean just this. So that would be the difference between the TSCheck and Typewise.
So applying the type inference being just memory while it's compiling?
I'm sorry, I have like a lot of trouble hearing you.
That's fine. Applying it where?
To the file itself. So it would actually like go through the file and add these type declarations, Typewise would.
And then TSCheck?
TSCheck would just apply the, so like over here, right, like the TypeScript compiler is looking at this and saying like, hey, this is an array that can contain anything. This is the best type, you know, I can infer for you. But it won't modify the file at all. And so that's the difference between TSCheck and Typewise.
So TSCheck is a thing that you run on a JavaScript file to check the types.
Yes.
Whereas Typewise is, okay, I have a JavaScript file, I'm going to change the extension to TypeScript, run Typewise on it, and it's going to generate all the type declarations for me, right?
Yes. And Typewise is not super mature. I will say that. So I would be very hesitant on running it and pretending that it's going to give you the right answers for anything. But it's a tool that exists. And once again, it's a tool that exists because types and type inference enable a new set of tooling that just isn't possible without types or without surfacing those types.
So just how many hoops do you have to jump through with Webpack to get TypeScript stuff to all like?
That's a really hard question to answer because, you know, the Webpack pipeline for people could be really weird, right? Like sometimes you see that pipeline, have like 4 or 5 different stages, and sometimes you see it like 3, right? But generally, you can pretty much add it at the front. The integrating it with Webpack is actually a pretty well trodden path, so you'll find a lot of documentation for that. Integrating it with your test runner, however, so like Jest, right, or Enzyme, that can actually be a little bit difficult, right? Because usually test runners don't run through Webpack.
Yeah.
So like I can't show you, but like there's some like weird like Jest plugin that like runs the TypeScript compiler. It's like a weird hacky way to like run it, be able to write TypeScript code in your tests.
Just with TypeScript is not as fun starting off. It works well once you get it going though.
Yeah.
Decently well.
I'm really hoping that all of the hype around the TypeScript plugin for Babel is true, because then you can just have a single Babel, define file, right, where you like run these transformations, and then your first one will be TypeScript, and then Jest already knows about that, right? But it's yet to be seen. I really hope that that's the case.
One of the problems, our team recently started using TypeScript on a project, and one of the problems we've had is in mocking dependencies, writing tests in TypeScript, mocking dependencies. Do you use, and I've looked at, I don't know the name now, TypeMock and another one, and I mean, they seem to do what we're looking for, but they have there's a lot of work involved in writing those mocks and in creating those mocks. So what we've ended up doing is kind of just getting around strong typing by just creating JavaScript objects of any type and then using those as dependencies. What's been your approach, and what have you found as far? I mean, do you use any sort of mocking framework?
I don't use any sort of mocking framework besides just what's built into Jest, and I do the same approach. I just cast it to any in order to like get the compiler off my back.
Yeah. It seems like the dynamic qualities of JavaScript, like on one hand, we have TypeScript to like nail that stuff down, but when it comes to testing, it's like, well, we really want to be as dynamic as possible there. So yeah, it's been tricky to balance that.
Yeah.
But we're not. I don't think we're like getting it. I mean, our shop at least isn't getting like a ton of benefit. I think from writing tests in TypeScript. Kind of gone back and forth a little bit.
Fair enough. Yeah, I would say, yeah, I haven't assigned types specifically to my tests. I'm just like running standard, yeah, I'm not applying any types to my tests specifically, just to my code base.
Yeah, a lot of the typing frameworks seem to rely really heavily on generics, which, as a shop that's, for a lot of people that don't know TypeScript and don't come from language backgrounds where they have generics, so that's a pretty intimidating step.
In those people's defense, I'm pretty sure like 50% of Java programmers aren't comfortable with generics either. Generics are definitely like one of those hills where like it is super steep, and that's one of the unfortunate things about that learning curve. And another great example of like when it throws a type error and you're using generics, you're like, this is all garbage to me. This means nothing. I know 3 of the words you've said, and 2 of them are the.
What's a sign that a project is a good candidate for conversion to TypeScript?
I would say if you're looking to refactor the code and there's no tests, I think it's a lot easier to write types for a project than trying to staple on tests. I would say that that is a really good use case for it because then the types act as a sort of like small unit tests for your refactor.
I would also add, I'd say anything where your data is more complicated than your visuals and your logic would also be so like anything where you have an extensive complex model that's easy to lose track of in your head, having TypeScript there to kind of remind you of it and enforce it on you can be really valuable. Or where you have, I think also where you have a lot of logic that you need to make sure is very strictly checked.
What platforms is this run? Is it run, for instance, on Linux?
Yes, yeah. So I know it comes from Microsoft, and they now actually run Linux. Right? For so long, none of their tooling would run on, anything that didn't have NT in its name, right? And so yes, it runs because it is built on Node. It runs anywhere that Node runs. So whether that's your Raspberry Pi running an ARM processor, all the way to your machine running your specific really finely tuned version of Gento, right? I guess nobody tunes Gento anymore, right? But that was like the thing to do. That was like the thing to do in like the early 2000s, right? Is like.
How about like for work though? Like people can't do that for work.
Well, I mean, who doesn't like blowing up their machine every time they recompile a project? Anyway, sorry, that's like a super like nerdy joke.
Sorry, a little bit unrelated.
Yeah.
But more so related to Gentoo. Why are we not using NixOS now?
I really want to. I hate Homebrew. I absolutely hate Homebrew.
I only use the package manager. I never use the
yeah.
actual like.
Yeah. Oh, yeah. I'm sorry. I'm confusing those two. You're right. It's a separate project. But hopefully one day, right? Like the fact that like determinism was not like a fundamental factor of computing, I think, is going to continue to bite us for years to come. Maybe one day.
I was curious about like what if you come from the other side? What if your day job is debugging C++ templates and you actually have reached an understanding of the difference between R value and L value, and your favorite language at home is Haskell? Like, how powerful is this type system? Like, are you at home? Are you gonna like?
Yeah. So it doesn't support type classes, right? And like every Haskeller and like now walks out the room, right? So it's not as powerful as Haskell. But it does move a little bit, there's like some pushes in that direction. I would say, it's hard to like compare it to something. I would say kind of like Elm. Are you familiar with like Elm and their type system? They very much like don't support type classes.
Sure. I know I've seen a little bit about Elm, but actually my question was more like, forget I said Haskell.
Okay.
But like more object-oriented, like, very intimate with Java or like something like Scala that is like inheriting space, not necessarily like the Miller Hidley sort of.
Yeah, I think they'll be able to pick it up really quickly. Yeah, it's once again, like I don't know if there's a better company that supports backward compatibility besides Microsoft, right? The fact that they call their structural typing interface, right, is that's directly from C# and Java, right? So like they're aiming for that crowd, they're trying to make it as easy to jump onto TypeScript as possible, even though the name interface in the JavaScript world makes no sense at all. So yeah, I think they're definitely aiming for that market. Cool. Well, thank you so much for coming out. I am, obviously required by my employer, right? Because every software engineering firm is always hiring. That's just true about every software engineering firm. ShowClicks is hiring. We do TypeScript. We also do React and React Native and, all of the other buzzwords, whatever. We also do PHP, but but we also do the other things. But we are hiring in a variety of different roles, whether that's UI developers, software engineers, security engineers, DevOps, or even product managers if you want to diverge from your software engineering and go more towards product ownership. We're hiring for those roles as well. With all that said, thank you so much for coming.
So, we need talks. So, can get in contact with me through Meetup, some other way. Come find me afterwards if you think you might have a talk idea, but you don't want to tell me what it is because you want to go write it on a notepad first and make sure you like it. I mean, I can give you my email address and you can get in touch with me. But we do need talks, so I would love to hear from you if you do. If you haven't given a talk before, I'd love to give you a little bit of help if you need it or something like that. If you have a cool idea for a talk that is about JavaScript, I would love to hear your idea and get a talk going. So, yeah. Hang out afterwards, talk to each other. Sometimes we might go down